We are going to start with analyzing graphs of polynomials. We're going to start with the concepts, and then we'll go ahead and move into the details, because if you don't understand the concepts, the details don't really make any sense. They become disconnected to the actual understanding. Different polynomials, there's all kinds of different shapes, all right? There's several different looks they can have, and we're going to look at all of these. And there are basic things or basic clues that you can get from the polynomial based on what we've learned so far. And we're going to start with that, the conceptual idea of what it is you're looking at, and then from there we'll go ahead and move on to the actual details of how to find the specifics of a polynomial. So when you're looking at a polynomial, you can determine the degree of the polynomial. For instance, if it's a second degree, x raised to the second power, x raised to the fourth, based on what I'm calling some clues. For instance, the first one here I have is end behavior. So when we look at end behavior, we want to ask ourselves, what is happening to x, or what is happening to y, as x goes in the positive and negative directions? So as x goes this way, what is happening to our y values? And as x goes this way, what is happening to our y values? Okay, so if you look at this first graph, as we go this way in the graph, y goes down. And as we go this way, to the right of the graph, y goes up. Looking at the graph number 4, it has different end behavior. As we go to the left on the x-axis, the graph goes down. And as we go to the right on the x-axis, the graph also goes down. Okay, there's a big difference between these two graphs. You notice the end behavior goes in opposite directions. Here the end behavior goes in the same direction. What this means when you have these graphs going in different directions in end behavior is you have either a graph of odd or even degree. And that's how you can tell. It's odd degree when the graph goes in opposite directions. And what are odd degree numbers? Well, it could be a 1, it could be a 3, or it could be a 5, which would be, for instance, x to the first, which is just a line, right? Or you could have x to the second, or the third, I should say. This could be a third degree graph, or this could be a or a fifth degree graph. Okay? Something like that, where I didn't put a 1 here because x to the first is just x. Now, if it would look like this, where you have your end values going in the same direction, which for instance would be here, they're both going down. Let's see, here both the values, you got them both going up, right? So here they're both going up. It doesn't matter whether they go up and down. The fact is they're going in the same direction. Here they're going in opposite directions. Here they're going the same. So this graph would be even degree. And this graph would be odd. So right away you can get a clue as to whether your graph is odd or even looking at the end behavior. That's your first clue, is am I looking for an x to the odd power or am I looking for an x to the even power? So what that tells me is my end behavior can be determine what degree my graph is. Is it odd or even? And here where it says absolute or global maximum, that's literally what it's asking you, is what is the absolute maximum value at the ends of the graph. So end behavior is also known as absolute or global maximums. Okay, so that gives you a clue right there. Is your graph going to be odd or is it going to be even? And I had put this, I'll go ahead and put this back. So this is odd. This pen doesn't write very clear, so I'm trying to... The next question, or the next clue you look at, is the number of turning points, local max or local min. That's what you're asking yourself. How many local max or mins do you have? So here, local max or mins are your turning points, all right? They're the same thing. If you see local maximum or minimum, you're asked for the turning points. You have one here, 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 and here. You have a turning point for this graph here and here. And then you have no turning points here. The graph just constantly goes. So we have, I'll put the number, we have 0 turning points here. We have 1 turning point here. We have 3 here. And here we have 2 turning points. All right. So this is where you can get another clue. So we knew this was odd, right? So that means it's going to be either a first degree, a third degree, or a fifth degree polynomial. It has 0 turning points. The minimum degree of your graph is based on the number of turning points. So I have 0 turning points. The minimum degree is one more. It can't be, it has to be more than the number of turning points. The number of turning points has to be less than the minimum degree, all right? So if there's 0 turning points, I have to have at least a degree 1. Because I know it's odd, and I know it has to be more than 0 turning points. This graph has one turning point, and it has to be even degree because the end behavior is the same. So if it's bigger than one turning point and it's even degree, the minimum degree has to be at least an x squared. Okay? This graph is, again, this is an even graph because the end behavior goes in the same direction. They both go down. It has three turning points. Well, the only even polynomial that's bigger than 3 would be it has to be at least a minimum of an x to the 4. Okay? This has 1, 2 turning points. It's an odd graph because the end behavior is going in opposite directions. If it has 2 turning points and it's an odd graph, then it has to be at least an x cubed. That's the next highest odd power you have above number 2, which is the number of turning points. So that's the next clue, is the number of turning points tells you the minimum degree. Okay, the next thing that we want to look at, the next clue I should say is the number of zeros, x-intercepts, or roots. Those are all the same thing. They're just different ways to say it. So basically we're looking for x-intercepts. And the fundamental theorem of algebra says you can have as many or less roots than the degree of your polynomial. So the degree of your polynomial has to be at least as big as the number of roots you have. You can have fewer roots or zeros, but you can't have more. So this has one root. You can see right here at the crosses, that's your 0. So it has to be at least an x to the first. Well, we have an x to the 1, so we're good to go. This has 2 roots. So this has to be at least x squared because it can have a second degree polynomial can have 2, 1, or 0 roots. This has 3 roots, so it has to be at least an x cubed, but since it's even, that makes it x4. So these are just basically verifying the conclusions I already came to. And this has 3 roots again, so it has to be at least an x cubed, which this is, we've already decided that. So what we've just found too is the number of roots or zeros adds to your conclusion about your minimum degree. Okay? So we have 2 clues. They both matched. We got our end behavior, so we knew it was odd or even. From the number of turning points, we figured out what the degree had to be, at least had to be a certain level, the minimum degree. We also saw what the minimum degree had to be with our number of intercepts. The final clue that you're going to look at is the slope or the average rate of change for the overall graph. And this is what you do with odd graphs. For an even graph, you don't have to go through this extra step. But for odd graphs, it helps you to see is the leading coefficient, the highest power, going to be negative or positive. Well, this was a first degree graph. And the slope of this graph, this is a line, so the slope is obvious. It's going to be positive. It's going to be a positive coefficient. I'm not going to put a plus in front of it because you just don't put anything, all right? Let's find another odd graph. Here's another odd one. If you look at this one, going from here to here and finding a secant line that describes the average rate of change from one end of the graph to the other, from the left to the right, it's going to be going down. That means that this is a cubic and it's going to be a negative. You could have an a in front of here. If you read the book, it actually puts an a in front of here. So, because there could be a coefficient on the x squared, but I don't care about that so much as I know that you're looking at the sign. So there would be possibly an a other than 1. There could be like a 2x cubed, 3x cubed, but whatever number's there, it's going to be a negative, okay? For the even graphs, you don't have to look at the slope. You're just going to look at the end behavior, whether it's going down. You can think of, negative people frown. It frowns. This is a very crooked mouth, but it's still frowning. Okay? Or you can think of, and then here, both ends, this is an even graph because they're both going in the same direction, and both of them are going up. So that would be a positive. So when they both go up, you have a positive graph. When they both go down, your negative coefficient is going to be, your leading coefficient is going to be negative. So this is an x squared or quadratic, and it's going down, so they're both negative. This is a 4th degree, they're going down, so they're both negative. Here you have a, let's see, well, we'll do this in a minute, but they're both going up, so we know it's positive. So those are the clues that give you your actual sign of the leading coefficient. So those are the clues that give you the sign of your leading coefficient. And that tells you that the sign is going to depend on the direction. For the evens, they go up or down. For the odds, whatever the slope is, that's how you determine the sign. So let's go through and do a couple of these randomly just to see, just to kind of practice, put all 3 of these together. We're now going to look at these different graphs and just come up with the odd or even degree. That's the first thing you're going to check, minimum or maximum degree, or minimum degree, I'm sorry, and then the sign of the leading coefficient. Let's start with this graph right here. First we're going to look at end behavior. It goes down and up. So that therefore it has to be odd. We know that. Okay? Or odd degree, not an odd graph, but odd degree. The number of turning points are 1, 2, I didn't hit that right on the target, 2, 3, or 4. So it has to be, the number of turning points is n minus 1. It's 1 less than the degree, so there's 4 turning points. So an odd degree, that would be more than the turning points, would be a 5th degree. And we look at the roots. It has 1, 2, 3, 4, 5 x-intercepts. And again, remember the x-intercepts, the degree of the polynomial has to be the same or higher than the number of x-intercepts. Your number of x-intercepts or zeros cannot be higher than a degree. Well, I have 5 x-intercepts, so I'm still good. It's a 5th degree. And then finally, you look at the sign. And this, if you do this is odd, so the slope is what you're looking at, the average rate of change of the graph from here to here. Going from this point, making a secant line to that, you see it goes up. The slope of that is positive, so it's going to be positive. So if I wanted to write this, it's going to be a positive. There could be a coefficient in front. It could be a positive ax. I don't know if there's a coefficient or not. It's going to be to the 5th degree. Okay, so that would be the best that I could do as far as estimating what it looks like. Okay, I guess we could go ahead and just decide if these are odd degree or even degree. This would be, hopefully you see this, they're going in the same direction, or at least the end behavior for your y values as your x goes to positive and negative infinity are the same direction. So this is going to be even. I'll make the even graphs blue. This will be even, right? This will be even. End behavior is in the same direction. And the rest of those are odd. So if we go and change color, this is going to be odd because our end behavior is in a different direction. This has got end behavior in a different direction. This has end behavior in a different direction. This has end behavior in a different direction. And so does this. So there's clearly more odd graphs here than there is even. So let's look again at our even graphs, which are in blue, and figure out the next thing we want to know. We know it's odd or even, so we've figured that out. Now we want to know the minimum degree, and that comes from two things. It comes from the number of roots and the number of turning points. So here's an even graph. My number of turning points, I have one here, here, and here. And so there's 3 turning points. It's an even graph, so it has to be at least x to the 4th. And if I look at my number of roots, I have 4 roots. So yep, it's definitely an x to the 4th. So this is going to have to be x to the 4th. Okay, this has only 1 turning point and only 1 root, which is fine. It's an even graph. It has 1 turning point, so it has to at least be x squared. It has only 1 root, which is fine. It doesn't have to have 2, but it can't have more than 2 if that's a 2nd degree. And then finally here we have a even graph. It has 1, 2, 3 turning points, so it has to be at least an x to the 4th. Okay? And it has 1, 2, 3 roots, which is fine. The roots can be less than that. And when we get into multiplicity, we're going to talk about multiplicity a little bit later. But remember, if this is 4th degree, it doesn't have to have 4 roots, but it does have to have 4 factors. And that's where this one right here, this middle one, since it just touches, becomes a squared factor, and that's where you get your 4th factor. So you have 1, 2, and then 3, 4. But we'll talk to multiplicity a little bit later. So that's all the behavior of my even graphs. The last thing we want to do, we've just looked at the minimum degree. Now what we want to do is the sign of the leading coefficient. This is if they open up, they're positive. They open down, they're negative. Positive people are up, negative people are down. I mean, you can think of it like that. So this is going to be positive. I'll leave it alone. This is going to be positive, and this is going to be positive. So all of these are positive because the end behavior goes up for all of them. Now let's look at the minimum degree of our odd graphs. This odd graph here has a turning points 1, 2, 3, 4, so it has to be at least an x to the 5th. And when I look at my roots, I see 1, 2, 3, 4, 5. Okay, so x to the 5th. So the roots and the turning behavior, the turning points tell me I have to have at least an x to the 5th graph. All right. Here, this one has 1, 2 turning points, so it has to be at least an x cubed. Has to be one bigger, and it has 3 roots, so yeah, x cubed is what I get. That is correct for this one. And then this one has 1, 2 turning points, and it only has 1 root. Well, if it has 2 turning points, it has to at least be an x cubed, because you have to have a higher degree than the number of turning points. It only has 1 root, which is fine. It can have 1 or less. That's not a problem. It can have less than 3. It just can't have more than 3. This has, let's see, turning points. It has 1, 2, 3, 4 turning points. So it has to be at least x5. Remember, this is odd, so it has to be odd degree, but it has to be at least x to the 5th. And I have 1, 2, 3, 4, 5 roots, so that works. I got plenty. 1, 2, 3, 4 turning points. So this is again odd, so it has to be at least an x to the 5th. And I have 1, 2, 3, 4 turning points, which is fine. This would be a double root where it's just touching the x-axis, so I have enough. So that's good. So everything, I know the degree of my different odd functions. Now I want to know the sign. If you go from left to right, you start with your end behavior. This is going to be a positive slope, so that's going to be a positive x to the 5th, or it's going to have a positive sign. For this one, it's going up and down. If we do a end behavior, we're going downhill. As we go left to right, it's a negative slope, so this is going to be a negative x5th. This go from left to right, you have to go up, so that's going to be a positive. Starting from left to right, going from basically arrow to arrow, we have to go down, so this is going to be a negative. This will be a positive, and so that's how we would determine our signs of the different graphs. So that's a pretty good explanation of what you're looking for. The details are finding out exactly what the x-intercepts, the y-intercepts, and what those factors where it crosses the axis are. So we've just kind of got a general overview here of what these graphs look like and how to determine the general idea of whether it's positive, negative, degree, etc.